Friction is the force that resists the motion of two surfaces sliding against each other. That would be caused by the interaction of microscopic bumps on surfaces as they rub together. Microscopic bumps would be demonstrated by this sandpaper. Object would be this quarter, and then a smooth surface would be my desk here. So you'll see, you can rub your fingers on sandpaper and you can feel that's rough. So let's see what happens when just barely like, you see that it went slow. Now let's do the same thing on a table. See, it's going a lot farther than on sandpaper because there's not like as many like bumps as on sandpaper. There's less friction. There's more friction on the sandpaper than on the table. That would be an example of kinetic friction, because kinetic friction is the motion between moving objects. That's what's making it slow down instead of just gliding on forever, like you would see at a like when you play air hockey. You see that the puck just kind of like glides around without anybody doing anything. So there is another one. It is called static friction. That's what keeps it from just moving around. Like, friction is keeping it in place. My hands are like behind the camera. It's not moving. That's where static friction comes into place. If there was no static friction, just be moving around like that. But there isn't. So another type of friction is called air resistance, or drag. It's a friction that is created as an object collides with air molecules, like falling objects. When you drop an object, it will fall toward Earth at a constant speed unless there is air resistance. So here we have a paper ball, just a regular paper ball, and we're going to drop it. See? Nothing happens. Falls at a constant speed, little to no air resistance. So let's see what happens when we uncrumple it, and we get to witness the most horrible thing that has ever been printed on paper: algebra. Anyways, so let's do it again. Dropping. It's going down a lot slower. Why? Air resistance. The air is pushing against the bottom because it's trapping it, like a balloon traps air, and the air makes the balloon expand. It's pushing the rubber outwards. Same with this. It's pushing it upwards, but it's still able to fall down, but just at a much slower rate than with a regular crumpled up piece of paper. So it's kind of like a parachute. I mean, a parachute is much bigger, so it makes more air resistance, keeps you from falling down to your death and breaking your finger.